This video will demonstrate how to find sample size for desired margin of error. The margin of error formula when we're dealing with one proportion is equal to z star times the square root of p hat times 1 minus p hat over n. Oftentimes when we're doing a study, we know the end result that we want in terms of margin of error. Like maybe we want our margin of error to be 3% or 4% or 5% in the end. If we know what margin of error we want to end up with, we can figure out what size sample size we're going to need in order to obtain that margin of error. To do that, all we need to do is take that margin of error formula and solve it for n. When we do that, we get this formula right here. Using that formula, we can plug all the things that we know in and use that to figure out what sample size we are going to need if we want to obtain a certain margin of error. Let's break down the different pieces of this formula, starting with z star. Z star is based on our level of confidence, so it's based on C. The ME in our formula here, this is what our desired margin of error is. So if we want our margin of error to be 3% in the end, then we would use 0.03 for ME in this formula. So this here is our desired margin of error. And P tilde is going to be our best guess for what P is. Sometimes we have something we can go off of, maybe some historical data, a pilot study that's been done. Maybe we're doing some kind of political survey and we did a similar political survey last week, and we could use that as kind of a starting point for our P tilde. Other times we might have absolutely no idea what P is going to be, and in that case we should just use 0.5 for P tilde, because using 0.5 is going to give us the largest sample size in the end. It's the most conservative estimate that we could possibly use. Some other things to keep in mind when we're using this formula is that we need to make sure everything is in decimal form. So the ME needs to be in decimal form, and also the P tilde needs to be in decimal form to get the right answer. And the other thing we need to remember is that we always round up. So let's look at an example. PTC is a substance that has a strong bitter taste for some people and is tasteless for others. The ability to taste PTC is inherited. About 75% of Italians can taste PTC, for example. You want to estimate the proportion of Americans with at least one Italian grandparent who can taste PTC. Starting with the 75% estimate for Italians, how large a sample must you collect in order to estimate the proportion of PTC tasters within plus or minus 4% with 90% confidence? All right, so here's our formula for figuring out sample size for desired margin of error, and I like to kind of just make a list of all the information that I'm going to need before I start plugging things in. So starting with Z star, and Z star is related to our level of confidence. We're also going to need to know ME, that desired margin of error, and P tilde, our best guess for P. So confidence level, we want to be 90% confident. And we saw when we looked at confidence intervals that Z star for 90% confident is 1.645. The desired margin of error that I want in this problem is 4%. And we always plug that in as a decimal, so I'm going to put 0.04 for my value there. And then for P tilde, it told us to start with the 75% estimate for Italians, so I'm going to use 0.75 as my P tilde. Again, always using decimal form for all of our percents or proportions there. Now I can plug everything into my formula. So I'm going to get 1.645 divided by 0.04, that quantity squared, times 0.75 times 1 minus 0.75. Now I'm going to just start working on the individual parts of the formula here, starting with this first part. So I'm going to take 1.645 divided by 0.04, which gives me 41.125. Then I'm going to square that quantity, and I'll write down this intermediate value here. I get 1691.266. All right, then I'm going to take 0.75 times 1 minus 0.75, so 0.75 times 0.25, which gives me 0.1875. Now I'm just going to multiply these two values together, and that gives me 317.112. So we're not going to just sample like a part of a person, like maybe just, their leg below the knee or something like that. We would sample the whole person. So we always, always, always round up for sample size. It doesn't matter what decimal number is beyond the decimal. If there's any number beyond the decimal, you always round up. So in this case, that means that we need 318 people in order to end up with a margin of error of 4%. Let's look at one more example. Suppose you wish to estimate the proportion of ACC students who work full-time and go to school full-time. You have no idea what this proportion might be beforehand. What size sample would you need in order to estimate this proportion within plus or minus 3% with 99% confidence? Again, here's our formula, and let's write down all the important information before we start plugging things in. So looking at my formula, I know I need to know Z star. Z star is based on my level of confidence. I'm also going to need to know the desired margin of error that I want and have a value for P tilde. So starting with my level of confidence, this time I want to be 99% confident. And the Z star for 99% confident is 2.576. The desired margin of error that I want is 3%. As a decimal, that's going to be 0.03. And for this problem, they don't give us any value to use for P tilde, nothing to start with. In fact, they say we have no idea. And if we have no idea, then we use 0.5, or in other words, 50% as our value. Now, one thing that sometimes students kind of confuse here is a lot of times we talk about alpha being 0.05, and this value here is 0.5. So just make sure you're aware that this is 50%, not 5% that we're looking at here. Now I can plug everything in. So I'm going to have 2.576 divided by 0.03. That quantity squared times 0.5 times 1 minus 0.5. Working through my equation, I start with that 2.576 divided by 0.03, which gives me 85.866666 repeating. I square that, which gives me 7373.0844. Write that down, 7373.0844. Times, then I have 0.5 times 1 minus 0.5, so that ends up being 0.5 times 0.5, which is 0.25. There's a point. Kind of a little high in the air there for a point, but you get the idea. So I multiply those two numbers together, and I end up with 1843.271. And again, we always, always, always round up, so that really means that I need 1,844 people in my sample if I want to have a margin of error of 3% at 99% confident. Just a couple other notes about things that could potentially go wrong for you when you're trying to do these calculations. One of the most common mistakes I see is people that forget to square it here. Maybe because the little squared symbol is so small, cute up in the corner. It seems to get left off. Either that or people multiply by 2 instead of squaring something. So make sure that after you write down all your numbers, you don't forget the squared part on that one. If you square things, write numbers as decimals, and remember to round up, then these problems should be a breeze for you on the exam.